Folks, so this Math 110 problem is known to cause students problems, so I wanted to make a video about it. It's kind of a neat problem. We have a sporting event. The scoring area shown here consists of 4 concentric circles on the ice with radii of 6 inches, 3 feet, 4 feet, and 7 feet. Okay, then if a team member lands a 43-pound stone randomly within the scoring area, find the probability that it ends up centered in the given color. So I want to write down in more detail these measurements. So you see the red circle, they tell me that that is 7 feet. So red, just to keep up with this, is a 7 foot. And it says, what's 7 feet? The radius. Okay, so you make sure you realize that's from the very center out to the edge. So that radius is 7 feet. And then the white circle, I'm going to color this, not white, because you would never see it. So let's do that all purple. Okay, so the white circle goes out 4 feet. Now you see where I'm getting that information from. It's just listed in the problem, really tiny up above, but it says 6 inches, 3 feet, 4 feet, and 7 feet. And clearly the biggest one is 7 feet. That's the red one. Again, the white one I couldn't do in white, so I just made it purple. That's 4 feet. How about the blue one? So the blue is the next size down, and it has a radius of 3 feet. And then we have a small white one in the middle. I'm just going to put small white. And it has a radius of 6 inches. Okay. Now it wants to know the probability of landing in a particular color. So they ask red first. What's the probability of landing red? And then the probability of landing white. And then finally the probability of landing blue. All right, so let's focus on the red. Now, to find the probability, we need to calculate area. So the probability is going to be, so the probability, and we'll write it at the top, of a particular color is going to be the area of that color. So how much area does that color take up divided by the total area. All right, so for the red, we need to know how much area the red takes up, and we also need to calculate the total area. So let's go ahead and calculate the total area of the entire circle. So that's all of the circles. So we know a formula for the area of a circle, right? So area is equal to pi r squared. So the total area of this entire circle is going to be pi. Okay, now that goes from the very center all the way out to the edge. That's 7 feet, right? So times 7 squared, which is going to be 49 pi. Now, for ease of calculation, I'm just going to leave it like that. I'm not going to type that in my calculator and get a decimal approximation, because that's going to go way wrong. You're going to see that the pi, leaving it in there, works out nicely. Now, again, that is the total area. I'm going to highlight it for you in some cute aqua color. There we go, 49 pi. We're going to need that at the denominator every time we do one of these problems. So the area of our color divided by 49 pi. Okay, now let's focus on red. Now you're thinking, didn't you just find the area of red? No, we found the area of the entire circle. Now red is a 7 foot radius, but we have to subtract out how big the white circle is in the middle. Do you see what I'm doing? So we need to find the area of that ring, not the area of the entire circle, but just that ring. So we have already done the 7 squared. That's the outside, okay? So we have, let's do 7 squared pi. And we're going to have to subtract out the white one, which is the 4 foot circle, so that we're going to subtract out 4 squared pi. Okay, so this is the area of the entire circle, including every color, minus the area of the white. And we got to subtract that out, and that's going to give us 49 pi minus 16 pi, which is, what's 49 minus 16? How about 33 pi? Okay. Now, to calculate the probability of it landing in red, you have to calculate the area of red, which is 33 pi, and then divide it by the total area of all the circles. That's 49 pi. And what's super convenient is our pi's just cancel out. Okay, so this pi cancels with this pi, and I'm left with, trying to find my blue pen. Okay, 33 over 49. I should reduce that if possible, but 33 only has factors 3 and 11, and 49 has factors of 7, and that does not cancel. So that is the exact value of the probability of red. Okay, now you'll know all of these calculations are not going to fit on there, but we've got red handled. That's 33 over 49. And when you do this problem, your numbers may be different, but how you calculate it is exactly the same. So let's move on to white. Okay, so remember, from the center of our circle to the edge of the white there, that has a radius of 4 feet, and that's what I have labeled over here. But now the white circle, if we just calculate pi r squared with 4 feet, that's going to give us a little bitty white circle, the blue circle, and the white circle together. So we're going to have to subtract some stuff out. So right now I'm focused on white. Okay, so the area of from the center out to the white circle is going to be 4 squared pi, which really is pi r squared, just written in a different order. But now we've got to subtract out the blue circle inside there, which is 3 squared pi. Okay, so that white ring is 16 pi minus 9 pi. Uh-oh. So my pen's not writing. Okay, so it took me like 15 minutes to get my pen to ink again. I'm getting angry. Okay, so I apologize. So 14 squared pi is 16 pi minus 3 squared pi, 9 pi. Well, 16 minus 9 we know is 7 pi. Now that is just the area of the white ring, right? Now the 16 pi is all the way from the center to the outside of the white, but the 9 pi I had to subtract out, which is from the center to the edge of the blue. So this is my white ring. Now, the probability of white is going to be the area of the white divided by the original area of the entire figure. The pi's cancel. 7 divided by 49 is 1/7. So the area, back up. I messed that up. I'm not finished, right? You know why I'm not finished? Because there's also white in the center. So instead of editing this video, I want you to show you where a lot of people make a mistake, because the white is not just that ring. We also have the small white ring that I have listed here. So let's address that also. So that's 6 inches. Now, here's something else that can mess you up. Everything else is in feet, right? Even my total area is in feet. So I can't use 6 inches. It's not going to be 6 inches squared pi. I have to turn 6 inches into feet. Well, we know there are 12 inches in a foot. So 6 inches divided by 12 inches is 1/2, and that's in feet. So that's 1/2 of a foot. So you have 1/2 pi, 1/2 squared pi, which is equal to 1/4 pi. I have to add that to my 7 pi before I can calculate the probability of white, right? So the total white area is 7 pi plus 1/4 pi. It would certainly help to have that added together. So I need to multiply by a least common denominator, which is 4. So multiply by 4 over 4. That's going to give me 28 pi over 4 plus pi over 4, which is 29 pi over 4. You see I'm running out of space, so I'm going to go to the next page. So remember the area of all of the white. This is the area of the white, which was the big one, which was 7 pi, and the little bitty one, which is pi over 4. Remember, so we had a half a foot, and then that's r squared pi, or pi r squared. And when you square 1/2, you get 1/4. You can write that as pi over 4 if you like. And I added the 7 pi plus pi over 4. I found a common denominator, which is 28 pi over 4 plus pi over 4 is 29 pi over 4. Now, what am I going to do? That's the area of the white. I'm going to divide by the original area. And I'm going to do that on the next page. So we have 29 pi over 4 divided by 49 pi. Okay? Now, remember, when you divide, you take a fraction and divide it by another fraction, put that over 1, you invert and multiply. So this is equivalent to 29 pi over 4 times 1 over 49 pi. The pi's cancel, and I get 29 times 1, which is 29, and 4 times 49, which gives me 196. Do that have any common factors? I'm just going to divide that by 29 to see. Certainly not 29. We know 29 is prime, and 29 does not divide into 196. So the probability of it landing in white is 29 divided by 196. Again, I almost messed that up because I forgot about the little bitty white part in the middle. So 129, and that is the hardest one, over, what was it? 129 over, no, 29 over 196. So let's fix that. Not 129, just plain old 29 over 196. Finally, let's calculate blue, okay? So the area of the blue, first I need to find the area, the area from the center to the edge of the blue. That's a 3-foot radius, okay? So I'm going to do pi r squared, which is pi times 3 squared, or 9 pi, okay? Let's go back to our page. So we're dealing with blue now. Okay, so it's 3 squared pi. But I have to subtract out that small white part that's in the middle, okay, because we have the blue, but the blue area that I've calculated now includes that little bitty white part, so I have to subtract that out. Okay, so we're going to minus out, get my pen working again, maybe it won't take me 15 minutes this time, 1/2 squared pi, because remember the radius of the little guy is 6 inches, which is 1/2 foot. Okay, so now I have 9 pi, and subtracting out that center part that we don't need, which is pi over 4. Now once again, kind of like when we added a minute ago, the little bitty circle in the middle plus the white ring, we had to find a common denominator. I'm going to do it again. So I need to multiply by 4 over 4. That's going to give me 36 pi over 4 minus pi over 4, which is going to give me 35 pi over 4. That's just the area of the blue. Now to find the probability of blue, I have to take my blue area, which is 35 pi over 4, and divide it by the total area, which is 49 pi. Now once again, I have to simplify a complex fraction. I am taking this fraction and dividing it by this fraction. So what I must do is flip the bottom fraction upside down. So it's 35, let me fix that, 35 pi over 4 times 1 over 49 pi. Remember, I flipped 49 pi over 1 upside down. It's 1 over 49 pi. Luckily, those pi's cancel again. So that leaves me with 35 times 1, which is 35, and 4 times 49 gives me 196. But here's the deal. That one will reduce. I know they both divide by 7. I could have even done that beforehand. So I need to divide both of those numbers by 7. I know 35 divided by 7 is 5. 196 divided by 7 gives me 28. So the probability of the stone landing on blue should be 5/28. Get my pen working. Now remember, your numbers may be different, but the idea is exactly the same. If you need me to work it out with your numbers because it's just driving you nuts, feel free to send me your work and I'll be glad to potentially find the error if you have one. I hope this helped you out. There is another problem in the homework dealing with squares that's very similar. The squares are much easier to do than the circles because when you find the area of a square, it's just side times side, right? So it's a little easier to do than the circles. You don't have to deal with pi. If you have questions about this or you find an error, please let me know. I hope this helped.